Everyone, yeah, we are live again today. Today we're going to be going through indices, and basically I'm going to give you the laws that governs indices. We have the multiplication law, we have the division law, we have the power law, we have the product power law, we have the zero index law, we have the negative index law, we have the root power law, and finally we have fractional index law. Now basically, the multiplication law and division law with power law are what you're going to be seeing in textbooks, if you're familiar with textbooks, but the remaining laws, you really need them in. Okay, now, what this multiplication law saying is saying that when you have two bases of the same values, then you have a multiplication, then it means that just pick one out of the base, the two bases out, then you're going to have one, that is your base A raised to the power of x plus y, because you have a multiplication here. So it means that if you have a division here, then the division will turn to minus. Okay, we also have our power law, which states that A raised to the power of x, y, which means that you are free to multiply the two powers together. Okay, we also have the product power law, which states that if you have two values with a power, then you are free to multiply the two values with that power. Then the zero index law says that any number raised to the power of 0 is 1. The negative index law also says that a raised to the power of minus n is equal to 1 over a raised to the power of n. That is, if you have, say for instance, you have your a raised to the power of minus 2 will give 1 all over a raised to the power of what? 2. Okay, similarly we have the root power law. The root power law states that when you have any number raised to the power of, say any number, say we have 1 over 2, then it's going to have the root of a, which also means that if you have a raised to the power of 1 over 3, means the cube root of a. Then finally, we have the fractional index law. We discover that this looks as if it's the fraction, which means that we have your y of the root of the base raised to the power of any number you see on top, or you can write it in this form as well. You're going to get the same answer. So some examples using the laws of indices. Okay, now here you can see this question 1, it has the same base here. So you just need to pick one out of the base here. Then you're going to have 5 raised to the power of minus 4, because from the law of multiplication law, this multiplication will change to addition, which is going to give you minus 4 plus 3. And if you solve it properly, you're going to have 5 raised to the power of minus 4 plus 3 is going to give you minus 1. Now you can also simplify this by saying 1 raised to the power of 5. 1 divided by 5. Okay. Now the second one here is going to give us pick one out of it. You're going to have 8 raised to the power of 3n. Division from the law, you're going to have subtraction. So you're going to have 3n minus n, which is going to give us 8 raised to the power of 2n. Now from the product power law, just use 2 to multiply everything out from inside the bracket. So you're going to have 3 a raised to the power of 3 times 2, then b 5 times 2. So you're going to have a raised to the power of 6 times b 5 times 2 is 10, and that's our answer. What's our answer? Okay, now we're going to apply the zero index law here. Zero index law says that any value raised to the power of 0 is 1. Then you divide 3 by 6. So we're going to have y 2 divided by 3 raised to the power of 6 times anything raised to the power of 0 is 1 times 1, which is going to also give us 3 here 1, 3 and 6 is 2. So I have y 2 multiplied by 2 is going to give me 4 times 1, which means my y power of 4. Okay, yeah. What you're going to do here is that you divide firstly with the numbers, then you apply your indices law to the variables here. So we have, if I divide here, I'm going to have 10 divided by 2 is going to give me 5. Then I take one base out from this variables here, so I have 3. This is division, change the multiplication from the law, minus 2. Then I'm going to have 5k raised to the power 1, which means 5k. Okay. Also, this is another example. Example 6 states that you will discover that the values here, the power raised to 1, 1, 1, and we have a 2 here. So applying indices law as well. Yeah, applying the law, you're going to just multiply everything out. If you multiply 1, 1, 1, 1, 1, 1 from the coefficient, which 1 multiplied by 2 is going to give me 2. Then, applying my indices rule, I'm going to bring just one value out, which I'm bringing 1p out. Then I'm going to have 1 plus the first one here, plus this one, then plus 2. Which means I'm going to have 2p raised to the power 1 plus 1 plus 1 plus 2 is going to give me 5. Which means 2p raised to the power 5. Let me write this properly. 2p raised to the power 5. Okay, example 7 now. Example 7. To solve this, you can rewrite this by saying 9 multiplied by 10 raised to the power of 9 divided by 3 times 10 raised to the power of 3. Now you're free to divide through here. 9 divided by 3 is going to give us 3. And apply indices rule here, multiply by, just pick one out. This is division, that's you change to minus. So I have 9 minus 3. And which means I have 3 times 10. 9 minus 3 is going to give me 6. And we discovered that indices is very simple. Very, very, very simple. Indices is just applying rules that governs everything, then you get your answer. There's no magic in it. Okay, let's solve example 8 now. It says, now here we are asked to find the value of x. Now, looking for the value of x here, we need to simplify this from the rule given to you. Now, you're going to apply the negative index law here, which means I'm going to have 3x raised to the power of 81 raised to the power of minus 1. I can also write it by saying 3x is equals to 3 raised to the power of 4. Okay, then, which means everything here implies 3x times 3 raised to the power of 3x is equals to 3 raised to the power of minus 4. If you multiply 4 times minus 1, then since they have the same base, you are free to cancel it because there's an equal sign here. Okay, you discover that they have the same base here. So that is just 1. You're going to pick 1 out, but here it's equals 2. So you are free to just eliminate it, and you're going to have your answer. Your final answer is going to give you x is equals to minus 4, and that is what we are asked to find the value of x. Okay, now second to the last, we have 5x squared multiplying 4x raised to the power of 0 multiplying 2x raised to the power of minus 6. Now, to do this question is very simple. Multiply everything out. If you multiply everything out, I'm going to have 5 times 4 is going to give me 20. Then 20 times 2, that is 40. So I'm going to have 40 here. Then using the law, you're going to have x squared multiplying x naught multiplying x raised to the power of minus 6. Which means that I can write this by saying 40. Using the law, bringing one x out, x, 2 plus 0 plus minus 6. Then I'm going to have 40x, 2 plus 0 is 2, plus times minus is minus 6. Then, which means that my final answer is going to give me 40x raised to the power of minus 4. That's very simple. Just use the laws there, you get your answer. Then finally you can just divide this straight. 24 divided by 8 is going to give me 3. Then applying the indices law, this is division, and which means you're going to the base there we have a minus value there. So you're going to have x raised to the power of 4 minus 6. Then I'm going to have 3x raised to the power of 4 minus 6 is minus 2. And that is your answer. We discovered that these questions are very simple questions. In our next video, we're going to go deep into it. We're going to go deep into it because indices is very, very useful. If you have not watched my video on logarithm, you should go and watch it because you're going to see that most of the laws I use in indices is what is in logarithm. I think if you like it, please just subscribe. Thank you very much.